Sir, are you speaking something? Hello? Sir, are you there?
Yeah, I'm here. So, can you listen? Can you hear me?
Yes, now I can hear, sir. Earlier, you are not audible.
Okay. Sorry. So I was speaking because no one was like talking from the other side. So I thought like I'm audible. Yeah. Okay.
No,
Thank
sir,
you
I
for.
think I have only joined.
Oh, okay.
Yes, I have only joined, sir.
Okay. Thank you
Yes.
so much.
Sir, can we start from the first slide, sir?
Okay then. Okay. Sure.
Well, actually, there was no participant earlier, I think.
Okay then. Okay. Thank you. Okay. So, so till now, like I have discussed about the basics of the fluidity, which have already been covered by the Professor Jha. So we discussed about the like that the fluidity is the basically the ability of a metal to flow and fill a mold, and then we discussed about the pouring temperature. Uh, so so pouring temperature is the most important controlling factor of the fluidity.
Yes, sir.
Yeah. So this I think this is already been covered in the lectures also. So
So, sir,
and
what should be the difference between the pouring temperature and molten melting temperature for like cast iron, how much we have to give the degree of superheat?
Yeah, so like it depends upon the from cast iron to cast iron. So so if you I don't remember the exact value, but if you can like go through some handbooks and all. So
Yes,
yeah, for having the exact values. Okay,
right,
so
right, sir.
yeah,
Yes, sir. So I think yes, first one is the degree of superheat.
yeah. So like after that, like we discussed about these formulas also. Uh, the fluidity is given in inches by the formula like 14.9 multiplying by the compositional factor plus 0.5 T minus 155, where T is in the point to ponder is that the temperature is in degree Fahrenheit here. So like if a simple problem comes in the exam that the carbon percentage, phosphorus percentage and silicon percentage are given,
Yes, sir.
then you can calculate the fluidity from this formula. Yeah.
So fluidity. So CF, how can we calculate, sir? Percentage of carbon plus
Percentage of
silicon by 4.
plus percentage of phosphorus divided by 2. So
But
if
sir,
you
in one objective question,
yeah
that was, I think you have told that it is by 3. Phosphorus and silicon divided by 3.
phosphorus and that is the for the carbon equivalent. You need to visit the lectures carefully. The carbon equivalent is given by like percentage of carbon plus percentage of sulfur by divided by 3. This is the like case of fluidity. That was the case for the carbon equivalent. Okay.
Right, sir.
So visit the lectures and make proper notes of those. So that will be helpful for you. Yeah. Okay. So these are the like the two problems like or two MCQs we I have discussed till now. So first one is the fluidity of a molten metal of cast alloys increases with an increase in degree of superheat, and then the other is in sand casting, fluidity of the molten metal increases with increase in the degree of superheat.
Yes,
So
sir.
okay, so I
Agree.
will yeah. One second. Okay, then we will be moving to the problem number three. So, which is the white cast iron has limited application because of can you like comment like why it is? I think
Sir,
someone
it
was
is C, sir, actually, very less ductility and hardness.
yeah right. So, so this is the correct answer. So if you want to uh, so these cast iron these they have limited application because of the lack of impact resistance and the difficulty in maintaining the structure in thicker sections. So
But sir, iron is having the good machinability, na, sir,
yeah,
and good damping capacity. So,
yeah, damping
and
capacity.
also it is having good fluidity.
Yeah, right. But
That's
they
why
are
it is used more in the market, I think, for
yeah, it is
heavy things.
yeah in the damping capacity so whenever is any the machine installation is there so they are used in the as a damper or to as a shock absorber, right? But when it comes to tensile strength and other things generally they are not used. So generally they are due to its large masses of carbides, like especially when alloyed, white cast iron has an excellent resistance against wear and abrasion. Generally these are alloyed and to for the other kinds of application because because of its brittleness. Generally cast iron has a limited range of application. Yeah. So the application have in which it is used, you told. Yeah. Okay, then we will move to the problem number 4. So
The
the
increasing in steel increase its tensile strength and decrease its ductility, sir.
yeah, right, yeah,
Option B, I think.
yeah, yeah, yeah. So the option B is like correct. So the increase in the percentage of carbon in steel, like it increases its tensile strength and decreases its ductility. So is there anyone else? So I think someone else has also joined. So if you have any doubt, like you can ask regarding this problem.
I
Or
have actually I have studied one graph related to this.
okay,
So in that there is something is varying, like percentage of reduction in area. That I don't understand, sir.
like I don't know, like which, like what the graph was in between. What was on the x-axis? What was on the
Like
y-axis?
how the properties of steel varying with respect to increase in carbon content.
Okay, properties like
Like sir, ductility increasing, right, sir?
okay, yeah,
And its tensile strength is increasing. Also, its yield strength increasing. Also, its ultimate strength is increasing. And
okay.
only is its ductility is decreasing.
So like you see, so as the carbon percentage will increase, okay, so it will be like the you can see like the tensile strength will increase
Yes, sir.
because yeah, and its impact energy like or if you can say like percentage elongation will decrease because
Yes, sir. Yes, sir. Yes, sir.
right, because it will tend to more brittle. So the more brittle it will be, like as the carbon content is increasing, it will be tending towards more brittle behavior. So that's why the percentage elongation will decrease. But it's
Right.
in right. So but also like uh, this tensile strength will increase. That is like so. What where was the confusion then? In which like section you have confusion?
No, actually, I don't understand reduction in area. Now it is clear that brittleness is increasing, so that's why percentage allocation elongation it
Okay.
is decreasing.
Okay.
Right, sir.
So from this you can correlate with the ductility also. So as the percentage of carbon will increase, the ductility will reduce, right? Because
Yes, sir. Yes, sir.
it is having more brittle behavior. That's why. And the hardness and strength also. So the hardness will increase, right?
Yes, sir.
And similarly, the strength will also increase. Okay,
Yes, sir. Yes, sir.
significantly.
Right, sir.
And
Fine.
okay, yeah,
And
yeah,
which of
uh,
the statements are correct about
yeah.
low
So
carbon
now,
steel? These
okay.
steels have carbon content more than 2.4. No. They are suitable for making sheets, strip, and welding electrodes. Sir, application, I don't know, but this is not low carbon steel is having the percentage of carbon is up to 0.2%.
Okay.
So I think first statement is wrong,
Yeah.
and second one it's okay, sir.
Yeah. Right. So the answer
Only
is
second C
yeah.
state, yes, sir.
Yeah.
The option.
Yeah. So you are right. Like which of the statement are correct about the low carbon steel? They still have low. They still have carbon content more than 2.4. This is wrong. So this has already been covered in the uh, iron carbon diagram. So you can go and see like and remember the hypereutectic hypo the different concentration for hypereutectic and hypereutectoid different alloys for the carbon percentage,
Yes.
and they're different temperatures because like they may come in the MCQ parts. Okay, so and one more thing is like which Professor Jha covered in the lecture classes about the shrinkage characteristics. So
Shrinkage.
I think you recall these. I think you should recall this, or that's why I'm giving a brief
Shrinkage, sir.
shrinkage characteristics. This was in the week number 7's lecture number 3.
Okay, sir.
So here the, the it was covered that solidification shrinkage was 2 times of the percentage of graphite carbon minus 2.8. and also it was like and then the percentage of like total carbon. This is given as like percentage of graphite carbon plus percentage of combined carbon.
Yes, sir. Total carbon is percentage of graphite plus percentage of combined carbon. Yes.
And then this graphite carbon, like it controls the solidification, shrinkage, and cast iron, right? And also like if it is like around 2.8 or more, it will be positive, else it will be negative. So like if in an exam like the problem comes like uh, if the like it was one problem was in the gate examination. You
Sir.
you can see like I don't know the year in which it was like there. So it was given that so generally if in problem it is given that the graphite percentage carbon is this much percent, then
Yes,
you
sir.
will then you can like see whether you need to take the shrinkage as positive or negative, right? So there was a
Okay.
problem. So there was a problem in the exam in which the graphitic carbon was given like this much percent, and majority of the students like taken it as a positive shrinkage, but in reality it was a negative shrinkage.
Yes,
So
sir.
so due to which like uh, so you need to consider these
Suppose,
two.
sir, graphite percentage is 2%. So this
Yeah,
is minus 1.8 and times the 2.
yeah, right, right. So if it is
So
around,
minus 3.16, like that.
okay, yeah,
So negative shrinkage, sir.
yeah, yeah, right, right. So this is the that's why I like covered again. So this I think majority of the students like don't like forget. So that's why I like covered again in the tutorial class. Okay. And also like so it is done. Then we will be moving to the problem number six. Like so, which of the following alloying elements primarily imparting corrosion resistance properties in a stainless steel?
Chromium, sir.
Yeah, right. So So you what you can do like you can study the effect of other alloying elements also in this steel,
Yes, sir.
right?
Because vanadium and tungsten, they are making carbides,
Hmm.
and chromium only helps in uh, the resistance of corrosion.
So
This is
basically, what
greatly
yeah.
helping.
So what happens like why it enhances the corrosion resistance is that the chromium it
Because I think it stops oxidation, no, sir.
yeah. So what happens? It forms a strong stable oxide barrier layer and inhibits further corrosion. So due to that strong oxide barrier, it inhibits the corrosion resistance. Okay,
Okay,
so
stable oxide layer.
yeah, stable oxide barrier you can say more like
Yes, sir.
okay. So this will be the correct answer. So so
B.
in yeah, so in a gray cast iron, carbon is present in can say
Flake foam, sir. A option.
yeah yeah right. So the correct answer is in the form of flakes. Yeah. So so this one is the correct answer. Okay. So if you like if you will move to the problem number eight, like which of the following has the maximum ductility? I think this is also an easy problem.
Yes, sir. I
Yeah.
think, sir, medieval iron.
Yeah, right.
But here, sir, one category is not mentioned.
Hmm. Which one?
Ductile iron.
Yeah, yeah,
So
right.
which one is better, ductile iron or medieval iron in terms of ductility?
Yeah, so which one you told? Malleable iron and ductile iron.
Yes, sir.
So
Because
like yeah.
medieval iron is, I think,
So what happens?
composed of processing white cast iron, sir.
Yeah, so what happens like uh, this graphite in malleable iron is called uh, so firstly what happens like in the malleable iron and then the ductile iron. So in ductile iron, if it is like given like this much percentage of alloying has been done, then you can compare these two, right? So we directly can't compare like the malleable iron and then the ductile iron. Okay. So if we
Okay.
if we say that on a normal case, then we can say like ductile iron will be having the higher ductility, but it also depends on the alloying element and other factors also. Okay.
Right.
Yeah. Okay. So this will have the malleable iron as the right answer. So have you seen like the previous lectures of the tutorial class also? Have you solved the problems and the other problems also like which we discussed in the class? I think
Yes,
this
sir.
is the I think
I
this is the
think,
first time you are like, attending this lecture.
yes, sir. Second
Okay.
time, sir.
Okay. Okay.
Last week also I have attended.
Okay. Okay. Okay.
Yes, sir. So malleable iron is having the highest, and
Okay.
which question number 9?
So question number 9 is
Principal element is stainless steel, chromium and nickel, sir.
yeah, right. So can you tell like why nickel is or why these two are the alloying element majorly?
So that I forget. But
Okay.
I know chromium is giving stable layer of
Okay. Right.
side,
So
and nickel I think also helps to in stopping the corrosion, sir. In
uh,
combination with chromium.
so what happens chromium is right because it helps in the corrosion resistance, but for the nickel it gives the your alloy significantly greater high temperature strength than other alloys. So nickel helps in high temperature strength. That's why it is added. Okay,
Right, sir.
and the second advantage is that the to resist the tendency to move slowly or deform permanently. Okay, so it enhances the creep resistance. So
Yes,
nickel
sir.
has two benefits. Firstly, at high temperature strength, it increases the high temperature strength, or in other words, we say red strength or hot strength because at
Yes, sir.
higher temperature. And then the second thing is the creep resistance. So the correct answer will be chromium and nickel. Okay. Okay, then so so let's move to the problem number 10. So the eutectic composition in iron carbon diagram has the melting temperature of around.
Sir, 1140, sir.
Yeah, right.
Eutectic temperature.
Yep. Mhm. Okay,
Sir,
then
these
yeah.
questions are of assignment, sir.
Yeah, these questions are from assignments. Yeah.
Right, sir. Right, sir.
Yeah. And another problem is that in ductile iron, graphite exists in.
Sir, D in the form of spherical nodules.
Yeah, correct. So, have you went through the theory of all these?
Yes, sir.
Okay.
I have tried, sir.
Okay.
Tile iron.
Okay, then which of the element adversely affect graphite nodule content in the ductile iron casting?
So, which of the element adversely affect graphite nodule count in? Sir, I think sulfur. You have told
Yeah.
earlier. Sulfur
Yeah.
is giving something negative
Yeah. Correct. Correct.
effect. So
Mm,
it decreases the nodule count in ductility. I think ductile iron. So it can reduce the ductility. I think further.
yeah. Right. Right. So what happens the in case of high sulfur content in steel what happens it produces a negative effect on the mechanical properties. What
Yes.
it like the crack formation generally basically what happens, they form sulfide. Okay, so due to which that the fatigue failure happens. So they reduces the fatigue resistance capacity of your material, which results in the reduction of intergranular strength and further the melting point of the steel also, because they form the sulfide. Okay.
Right, sir.
Okay. So then, can you comment on the problem number three, problem number 13?
Group number one. Sir, actually, can you zoom, sir, little bit?
Okay, one second.
Actually,
Is it
this is.
is it okay now?
Yes, sir. Fine, fine, sir.
Okay.
Sir, A is sand casting and sand casting. Sand casting. A for 3. Plaster molding shell. Investment casting. D for. Sir, A sand casting for 3. We can match.
Okay.
Parts have, sorry, minimum post casting processing is required for sand casting.
So whenever these type of problems come, uh, there will be some what you can do.
Yes, sir.
Uh, you firstly, like if there is anything written about investment casting, so it has the best surface properties like compared to the conventional. Nowadays,
Yes, sir.
processes have came which are better than investment casting also, but generally the investment casting will be having the good interior and better properties than other. So you can directly match the D with 2 like that. The parts have hardened skin and soft interior, right? So in another there is nothing about the soft interior and other written. So you can directly match D with 2.
Yes, sir.
And then if you move to the other thing, then you can after matching the one problem, like in the exam it will be given like A with 2, A with 3 and all, there will be options. So
Right, sir.
now the two options will be eliminated,
Right.
because no one will be knowing all fours. So elimination method is better. Now after that, if you talk about say cell mold casting. So in generally generally it is used for circular shapes only. Okay. So this is how you can match your problems and you can solve these. But if
So
you
I think symmetrical and circular shapes can be done by centrifugal casting.
yeah, centrifugal casting can all is
Okay,
also
shell molding is there.
yeah. Centrifugal casting is also like for hollow, but then you need to go and visit what is the thickness for the hose and other parameters are also, and what is the now you have
And I think so plaster molding can be done for only non-ferrous. No?
so plaster molding, if you will see, so it has a minimum post casting process. Okay, because you go and then break the your mold, plaster mold, and then in between your pattern is ready. Okay,
Right.
directly your, so it has the minimum post casting process. And
And
then if you
plus, right, sir.
sand casting, if you see, it has the parts have soft skin and hard interior, because a lot of uh, because it doesn't have good proper because it is using sand and it has pores in it, and due to the lesser what you say, like due to the lesser permeability and porosity, your surface is generally rough. That's why the hard interior comes in the sand casting process. Okay.
Right, sir.
Okay then, and some more things about the investment casting are that, like it is also known as the lost wax casting or precision
Yes,
casting also.
yes, sir.
And the major disadvantage is that it is used for less than 10 kg only. Okay, and
Yes,
then I think the theory you have already read, like the pattern is made of wax, like which one second.
yes, sir.
Yeah, so this is the procedure how the one second. So this is the procedure how the injection molding, investment casting, or lost wax casting takes place. So firstly, the wax is injected in
Yes.
different, and this is the assembly parts you have shown, like, and then your cell is prepared, right?
Then it is dipped in the slurry.
Yeah, it is dipped with the slurry, and then like it is after the particular heating and all, it
Yes,
is de-waxed.
yes, sir.
Then finally, it is the cutoff, and your finished casting like get you can get. And
Right, sir.
further, it also utilizes vacuum to reduce the gas defects, like pinhole defects and other porosity defects. And the other parts is like that the turbine blade, jet engine parts, medical implant for gold ornaments, it is also used. And the another major advantage is that very thin sections of even like 0.75 mm can be casted by this. So investment casting is highly like hello. Okay.
Yes, sir.
So,
Yes,
okay,
sir.
okay,
Yes, sir.
okay, okay.
The
So
casting
investment,
method also known as the lost wax method. Yes,
no,
investment casting.
okay, okay. Firstly, like let's solve the problem number 14.
14, 14, sir.
Yeah, yeah. So,
So here, actually, sir, in 14 for sand casting, option number 5,
so
and
actually, so actually, in the problem number 14, only four will be matching.
for
Okay,
just no, sir, 13. I'm talking about 13.
okay, 13. Okay.
Thought
So,
like cast for actually I'm verifying for sand casting we have choose the option number 5,
yeah,
for
right,
plaster molding option number 3,
right,
for shell molding option number 1,
yeah.
for investment casting option number
Option number
2.
two. Yeah, right.
Okay, sir.
Yeah. So let's move to the problem number 14 then.
Yes, sir.
So, okay.
Sir, investment casting, turbine motors, turbine blades, connecting rods. Sir, for connecting rods, I think option number D, drop forging.
Yeah, right. This is right.
And for centrifugal casting, option number 5.
Yeah, that's also right. Yeah.
And for
Investment casting, like we just discussed, like for turbine blades, it is used, right? So
yes, sir.
he will be matching with turbine blades.
Yes, sir.
And then can you comment about the centrifugal casting? You commented, no, right?
And
Yeah.
sir, die casting
Only
for
four will be
current.
matching. Only here, only four will be matching. Rest are wrong. Just to
Okay, sir.
confuse you.
So one
So
is
only
turbine blades is for investment casting.
right.
For centrifugal, it is cast iron pipes.
Yeah, right.
For sir, drop forging, it is connecting rod.
C5. Yeah, right. C drop.
Galvanized iron pipe.
So the the answer for investment casting is turbine blades. The answer for die casting is carburetor body. So die casting is
Okay, sir. Hmm.
generally used for carburetor. Okay. So what you can do, like you can make a short notes. So I have the prepared short notes for all these methods.
Right.
I will share in the this
Chat.
week's this week's this week's after in the PPT itself. So you can visit and go through like which one is used for which,
Right, sir.
right?
So
Okay.
that is available on the like. NPTEL
No,
dashboard.
uh, that I don't know, but all these lectures and the slides are being shared to you like on a weekly basis. So, so I think in
Okay,
the dashboard you can check once whether it is
fine.
in desk or else in the next week is the final I think tutorial class.
Yes, sir.
So in the next week, like if you don't find, I will be sharing the link with you. Okay.
Yes, sir.
Okay, then let's move to the problem number 15. So the casting method, also known as lost wax method, this we just
First
discussed.
option, sir.
Yeah, right.
Investment casting.
Yeah, right, right. So like these are the
Casting defects, sir.
yeah. Can you tell like which one is this defect?
Uh,
Like
sir, uh, sir, first one is uh, incomplete fusion, we can say.
yeah, but there is some
Incomplete
particular,
casting.
but there is particular name for all these.
Short, something. Cold
There is
shut.
yeah, right, right. It is a
First is
cold.
cold shut. Second, right
It
side,
yeah.
and right side is misrun.
Yeah, this has already been written.
Written, yes, sir, yes, sir.
And
And
another,
at the bottom there is left side cracks,
hmm the third
and
one is
the
the
right
hot clear.
side is the voids, solidification you can say, or there is one crack,
So this last one is the shrinkage cavity defect.
shrinkage cavity.
So if you like discuss like what is the reason for this, like can you know, do you know like why cold shut happens? Why this defect is like
Cold shut,
comes?
yes, sir, because I think they freeze earlier. Actually, they lost their fluidity at the end.
Yeah,
Actually, they
so
try to solidify. Yes, the whole structure is solidifying, sir. And at last, they are not able to make the proper bond. At just
yeah, right.
last.
So what happens in the cold shut? Like it is caused when like anywhere like there are suppose there are two streams will like we like the designers of the casting plan that after this much of distance they will meet. But what happens like while meeting in the mold cavity they do not fuse together properly. So
Yes,
there are discontinuity in the casting comes, and also like when the molten metal is poured into the mold cavity, like suppose there are more than one gates, multiple liquid fronts will have to like flow together
yes,
to become one solid, right? So whenever this will like more gates or like this will be the case, there the chances of the cold shut will be increased, right? So
yes.
the number of in the designing also the number of gates and other things also need to be taken care of. Okay, then the second defect is the misrun defect. Like, do you know like why it happens?
Yes, sir. Fluidity. Actually, it start freezing earlier, and due to the lower pouring temperature.
Yeah, correct, correct, correct. So what happens in the misrun, like uh, when the molten metal solidifies before completely filling the mold cavity? I think someone wants to join. Let me.
Right. It is not reaching to the
Uh,
last corner of the shape.
yeah. So what happens uh, when the molten metal solidifies before completely filling your mold cavity? So it leaves a space in the mold because due to the low fluidity of your molten metal or the low temperature of the metal, it like solidifies before and your like fluidity decreases. And for like in case of too thin section and improper gating system, this problem arises. Okay, so the gating design is a very important term in like solving this kind of problem.
Yes, sir. Getting design and pouring temperature we have to maintain.
Yeah, maintain and the design should be properly.
Right, sir. And something you have told, sir, for increasing the fluidity, like something is added. I
Yeah,
think
there are inoculants. Yeah,
inoc- inoculants.
yeah, inoculants or some additives. Generally, there are some additives are added for like which enhances your like fluidity also. So like and also you can like as we discussed like it also depends on your and silicon content also. So those things also need to be taken care in your I think someone was molten melt. Okay. So
Yes, sir.
Now the third one is the hot tear effect, like like why it happens, the hot tear effect.
Sir, I think when the fluid in molten metal is in like in hot state, it tears some wall. I think there is some crack generated in the wall, and that's why the molten metal flows in that.
So what happens, like suppose different uh,
That term is known as hot tear.
so you suppose like there are like different cooling rates of your molten melt.
Yes, sir.
So then there will be like so generally it takes place due to different cooling rates, and it is a defect that occurs during the solidification process.
Hot tear.
So yeah, right. So what happens that due to the differential cooling rate, internal stresses develop in your final product, and then these stresses what happens? These stresses more than your strength of the melt or the final product, and then cracks are expected. Okay, so generally the use of chills is utilized in solidification to avoid some these types of cracks. And then the final one. So so this is
Okay.
the shrinkage cavity.
Okay.
So
Solidification cavity. Sorry,
uh,
shrinkage cavity.
shrinkage cavity. So what
Sir,
happens like
actually, one more question is actually very close to this. Like, if we are having like two metals, na, their
hmm
solidification temperature different.
okay.
So, like, I think this is in welding. Like, we are adding the metal through the
hmm
electrode, है ना, sir?
Okay.
Then, uh, what would be the defect? So, it is like tearing effect will come
Like
due
I
to the
didn't.
cooling rate of the parent metal and the base metal.
Okay.
So, metal and the electrode material, allowing element,
Can you okay, I think
because they are having the different temperature melting points,
okay,
and also they are having the different cooling rates.
okay.
Due to this, I think this hot tear will occur.
Yeah, it may occur.
Yes, sir.
Yep. So this the shrinkage cavity, what happens? It is generally a void on the surface of your casting, and this also happens due to the uncontrolled solidification of the metal.
Yes,
Okay,
sir.
so to compensate these type of defects, proper feeding of your liquid metal is required, and also proper casting design is needed. Okay, so
Yes, sir.
now so these this table classifies the different defects in three categories, like surface defect, internal defect, or visible defects.
Okay, sir.
Okay. So okay then, okay then and then this is this I think you have already. So can you anyone tell what is this?
Sir,
So
actually,
can
this is, I think, mm, sorry, buckling? No.
no.
Sir,
We just discussed this
red tails.
no, red tails it is not. Red tail, there will be some extra material coming from your
Yes.
surface.
Okay, sir. Okay. Yes, sir. But this is, I think,
What I can say, this is due to the this is
wash.
this is no this is among these four, which is the just discussed. So you can eliminate and see which will be this one.
Sir, this is surface defect, sir.
So this is surface defect, right? But So like, can you name like which is this defect, like among this is either cold surge, misrun, hot tear, or single defect? This is one of these four.
Hot tier, sir.
Yeah, this is hot tear because like there is some tearing in your like material surface. You can see.
Right.
Uh,
Hot tier.
yeah, right. So this is like this is not cold set because there is no like improper like there are no two surfaces which are like not melted. So there is like every surface is completely melted. There is no misrun also because this is also not. And if you see about the hot tear, like this is your surface has been teared. That's why it will come in the category of hot
Visible
tear.
defect, sir. Visible defect and second lie stroke.
Yeah, this will be your visible defect, and then yeah, right, visible and then hot tear. Okay.
Yes, sir. So I think hot tier, cold shut, misrun, swell,
So
rat tail,
this is
wash,
a
and shrinkage shift. These are
mhm,
the visible.
defects.
Internal are the blowholes, porosity, pinholes, inclusions, and draws.
Hmm.
And surface defects like it is over the surface blowholes.
So one more question comes
This,
from this. Like, can you differentiate like what is the difference between the blowholes and the pinholes?
yes, sir.
Like, okay,
Blowholes are again actually due to the air entrapment,
okay,
and pinholes are due to the hydrogen coming out from that.
okay. Yeah. So generally pinholes are due to generally they are due to the hydrogen, while
Yes,
blowholes like can be due to the, any type of gas or any other entrapment of gas.
sir. What is
So
the difference between drop and scab? Actually, there was one question, no, sir.
okay, so this will be like I think someone
So drop is something when some material is fallen in the cavity, na? When we close the flasks.
yeah, right.
So that is known as drop.
Yeah, right. So
Okay.
like for you like we will be discussing
Scab.
this. Okay. So
This is
drop.
mismatch, sir.
Yeah, this is mismatch. But
Alignment.
firstly, like what was the question like drop and difference between drop and
And sir, previous slide, sir.
okay,
Scab.
okay, drop and scab. Okay,
Because penetration, I understand. When the liquid uh, flow like through the mold wall, so it will become like penetration.
okay. So what you can see like if you see the last part of this,
Sir,
uh,
sir, you can zoom this slide, sir.
yeah, 1 second.
Actually, this is very small, na? Not
Yeah, sure.
visible, sir.
So if
Actually,
you
yes,
so if you will see like about the drop part, and after that we will be like discussing about your scab difference between those. Okay.
yes, sir.
So in the drop defect, it occurs when there is a cracking on the some part. Like you were right, like there will be some cracking or some part of your mold will break and fall in your cavity, or like due to which, yeah. So these are generally the reason are like if you have not rammed your mold properly, like soft rammed and your sand has not proper strength, like it has low strength and you didn't add some good additives to enhance its strength and other things, or insufficient fluxing of molten metal, or insufficient reinforcement of sand projection in the core. While if you talk about the scab, you know why scab happens? Do you know?
No, sir. Scab, no idea, sir. Actually, I forgot.
Okay,
That's why
so
I'm asking, sir.
yeah, yeah. So firstly, like if you need to differentiate, firstly you go and see the defect, like how what is the shape of the defect. So generally the scabs are usually round or oval shaped. Okay,
Right, sir.
and they may have irregular shapes also, but generally usually they have round or oval shapes.
Right,
And
sir.
all and other thing is like they occur by splash or some boiling or casting or conditioning defect. So what happens like they are not due to the some ramming or low strength of your sand, due to those soft ramming and low strength of your sand. They occur
Yes,
by
sir.
splash, like generally some splash on your casting, like someone did or by mistakenly, or like they are also, they can be called as a mistaken defect, like they are due to the man's defect. Okay, so
Yes, sir.
scabs or buckle, they are also can be slightly related to buckle. They can be attributed to the searing at the cope surface. So okay, so due to the sudden splash, there will be some, due to the searing at the cope surface, they may result into this kind of defect. Okay,
Yes, sir.
okay. So now if we you see like the kind of defects. One second. So this is the shift or mismatch. You already
Yes, sir.
know this. Yeah, like cope or drag, they didn't like fit perfectly to each other, and then there is some horizontal or vertical displacement. That's why these kind of defects happen. Okay.
Yes, sir. Yes, sir.
So the reasons are loose box pins or inaccurate pattern or dowel pins. Okay, or some carelessness of due to the man which is handling this, or the misalignment. And if you talk about the swell defect, you know why swell defect happens.
Well, sir, yes, due to the mold cavity enlargement, na, sir, the body, we get extra
So
material over the surface.
so what happens like it is generally the enlargement of the mold cavity. Okay, so
Due to the heavy metallostatic forces
yeah,
of
right.
broken metal.
Metastatic foot. Yeah, right. Or the pressure or the localized enlargement of the casting. Okay.
Yes, sir.
So like these are the things which I wanted to cover in these. Do you have any doubts which you want to discuss? Any numericals from the previous classes or some other things you want to revise or
Sir,
anything?
actually, I want to revise, sir, C curves and S curves.
Okay. So in the next week, will you be joining? I will add those in my like uh, slides. C and S curve you want to revise. Okay.
Yeah, actually, yes, sir. That is
Maybe
the problem. And generally, I don't remember this carbon iron diagram. So
okay.
something actually there is some typical like curves at the top, na, where some critical point, where is solidus point, liquidus point, and eutectide point. That I understand hypo steel and hyper eutectide steel, but
Okay.
how these reactions below like 723 degree there is like no further decomposition. Actually, I forget some things
Okay. Okay. Okay.
of
So I
this.
will. Okay then.
So
Okay.
see curve how the bainite, perlite, and martensite forms.
Okay. Okay. I got your point. Okay.
And sir, where are your previous slides, sir? Have you sent, sir?
Yeah, I have like uploaded on the, so the previous videos are being uploaded on the YouTube. You can watch, and the, and also the lectures like PPT have also been shared with you, I
Okay,
think.
fine.
So I will like cover in detail the iron carbon diagram and your C and S curve.
Yes, sir. That's all.
And besides these, if any other topic, because next week is the last week, so if anyone else or you have like any doubts of this whole course, feel free to like tell me now, because I want to like clarify all the doubts before your examination. That's why. So
Yes,
beside
sir.
these two topics, if you have any other topic also, like feel free to tell me.
No, sir. Rest I understand, sir. Sir, numerical like from buoyancy force, something like that.
Okay.
Buoyancy force and sir, actually, and the gating ratios. In some books,
Okay.
it is gating ratio. Uh,
Okay.
some books it is written 1:3:3,
Okay.
and in some books it is like 1:4:4. Then I don't remember when in some questions it is coming, which we have to select.
Okay, so
In
the
some
gate.
it is 1:2:1.
Okay, so the gating ratio, like this problem I can cover now all itself, because this I have already covered in the previous also. So I have slides for that ready for that. And
Sir.
so beside this, any doubts? Because that
Yes, sir. Okay, sir. Almost okay.
okay, then I will be covering the gating ratio and the buoyancy force. I think I have something. And then beside these two, the your previous two doubts, I will cover in the next in the last weeks. Uh,
Yes, sir.
okay, so if anyone else has any doubt, feel free to tell me now, because after that, because next week will be the last tutorial. You can comment also if you don't want to talk or uh, say something. Okay, then 1 second, then I will be sharing the slides in which I have covered about the gating ratio. Okay, 1 minute.
Yes, sir.
Okay.